The title of my research proposal is Comparing Student Performance Scores in Chemistry Laboratory using Virtual Laboratory versus Hands-on Laboratory Activity. Computers have become inseparable to our young generation. It has become an integral part of their culture as they find convenience in getting knowledge, information, and communicate with simple touch of buttons or keys with their handy electronic gadgets. Majority of students now own laptops or tablets that easily connect to the internet. Almost all students own cell phones. Most of this has the capability to perform like a personal computer and connect to the internet. The emergence of internet provides an opportunity for exploring various combinations of traditional and online learning. Students nowadays give more time in exploring their internet on their laptops or tablets than conventional books. Computer games and applications have virtual reality themes that mimic reality as if you yourself are out there in the game. Advanced computer graphics have made it look like the game you are playing is real. Computer technology are also fast assimilating into our educational system as some schools have replaced books with ebooks in computer tablets. Some schools have also replaced their blackboards with a wide computer touchscreen that shows visually their lessons. Some schools have computer learning programs where the students simply sit over their computer and let the computer guide them in learning the lesson, hence eliminating the need for a human teacher. While the debate is still hot over whether students would learn better using these technologies than the traditional learning classroom, America's largest state-run online school, the Florida Virtual School, has announced in 2009 that it is abandoning its long-used hands-on labs for middle school students and replacing them with online simulations. This takes the debate farther with respect on the laboratory aspect of physical sciences such as chemistry, physics, and biology. Can the laboratory knowledge and skills required from our students be accomplished on virtual laboratory instead of the with hands-on laboratory where the students use actual apparatus and chemicals? Several studies have shown contrasting results. The study by Hawkins and Phelps and by Hall showed no significant laboratory compared to those exposed with hands-on experiments. However, the studies by Woodfield, Carnival, and Martinez et al. Showed those exposed to virtual laboratory outperformed those who went through the traditional hands-on laboratory. This paper compares the student performance of two groups of high school students currently taking up Chemistry 2, General and Organic Chemistry at the Philippine Science High School Cordillera Administrative Region at Erisan, Baguio City during the second grading period of the school year 2013-2014, exposed to the traditional hands-on laboratory experiments and exposed using a virtual laboratory activity. The specific Chemistry 2 topics for the experiment was on gas laws, Charles and Boyle's law. The two chemistry laboratories, two sections of high school chemistry students will be selected for this study. One group will be exposed to the normal hands-on experiments on gas laws in the chemistry classroom laboratory, while the other group will be exposed to a virtual laboratory using ChemLab. Hands-on laboratory. The students who will perform hands-on experiments were given the usual hands-on with the procedures to perform the gas laws experiments, Charles and Boyle's law. For the Charles law experiment, the student will follow the procedure in setting up the apparatus needed and gather data points relating temperature and pressure. They will plot these data points and infer from the graph the relationship between the said variables. Here, we expect a directly proportional relationship. As temperature increases, pressure increases linearly. For the Boyle's Law experiment, the students will learn the relationship between pressure and volume. ChemLab, Virtual Laboratory. The students who will undergo the virtual laboratory procedure will be provided personal computers connected to the internet to be able to access the online version of ChemLab. ChemLab is a chemistry lab simulations for the classroom, the laboratory, and the internet. Model ChemLab originated from academic work in computer simulation and software design at McMaster University. It has continued to be developed with extensive input from educators interested in the possible application of computer simulations for classroom and distance learning. Model ChemLab incorporates both an interactive simulation and lab notebook workspace with separate areas for theory, procedures, and student observations. Commonly used lab equipment and procedures are used to simulate the steps involved in performing an experiment. Users step through the actual lab procedure while interacting with animated equipment in a way that is similar to the real lab experience. ChemLab comes with a range of pre-designed lab experiments for general chemistry at the high school and college level. Users can expand upon the original lab set, thus allowing for curriculum-specific lab simulation development by educators. Methodology. In this study, the post-test experimental control group design will be used. This study will be carried out with the current third-year high school students currently taking up Chemistry 2, General and Inorganic Chemistry, the Philippine Science High School Cordillera Administrative Region at Rizan, Baguio City during this second grading period of the school year 2014-2015. The researcher is currently handling all Chemistry 2 sections at PSHS CAR and will select two of the three classes that are almost identical in terms of average intellect for this experiment. The specific Chemistry 2 topics for this experiment will be on gas laws, Charles and Boyle's law. One section will be designated as a control group will be exposed to the usual hands-on experiment, while another group designated as experimental group will be exposed to ChemLab, a virtual online laboratory. After the experiments, the students' performance will be evaluated using a 25 points exam to test the knowledge, theory, and skills they learn in performing the experiments. The mean average and standard deviation for each group will be computed to determine if the experimental group will perform better than the control group in the test. Statistical analysis. Does the test result mean that those who were exposed to hands-on experimentation still score better than those exposed with the virtual laboratory activity? A simple statistical test is needed and will be used for this study to determine if the difference in the mean scores between the experimental and control groups is indeed significant. Since we have data for the means and standard deviation, a simple t-test will suffice to determine the significance at 5% significance level. We test the data with the null hypothesis that there is no significant difference between the test scores of the experimental group and the control group. The two-tailed p-value will be computed for significance, that is, if the null hypothesis is to be accepted or rejected.